I'm just going to spend some time studying the source code for this playlist here. Highly recommend. It is by far the best playlist that I've seen on LLMs. And I downloaded the code here. I think I might try to convert this into Rust, but I'm not really sure because I haven't spent time studying the Rust libraries for this, which I believe is there's Candle, then I think BERT, and some other ones. I think I have two of them open here as well. I'm just gonna study the Karpatis, or I've pulled it up here. This motherfucker.
Andrei Karpati.
Yeah. So I'm just going to review his source code again, and then maybe try to translate it into Rust to see if I retain more the information. I'm just waiting to see if it's streaming. So basically, the thing that I have the hardest time with is the inputs and outputs. And there's a difference as well, which is kind of confusing to understand. But the first video is about a simple neural net, and the other ones are about large language models. So I think that they're not fundamentally different, but they are different. And I'm obviously going to start with the first video. I think it's cargo new to start repository. Cargo new this. I'm gonna have to change. The reason why I'm using Rust instead of C and C++ is because I'm kind of tired of CMake. The Rust is just easier to set everything up. I'm obviously just going to use the LLMs to ask for questions and stuff like this, and search for the Endo library. So basically, the way that I understand I watched a bunch of times, but the playlist, but it's still kind of hard to understand because I'm only gonna be able to fully understand if I force myself to do this. I'm trying to build myself. So this is a library for, I think it's dealing with tensors on Rust and the device as well. So obviously I'm gonna have to learn this. I don't know anything about this yet. And the way that I understand how it works is basically a direct acyclic graph of mathematical operations. So each one of the nodes is a value here, And basically what he does is build an equation that build a graph that encodes an equation. And that's basically all that the machine learning is. So yeah, I guess like this one is confusing because I don't remember what he trains with. And then I also think from what I remember that the code that I have here is slightly different than the one that he shows on the video. I think maybe he changed something and there's some information that is missing. Yeah, so this might be annoying to figure out. I have to clarify what was the purpose exactly of this one, so I can understand what are the inputs and what should I be aiming for the outputs. And obviously there's a lot of different paradigms, but I think for this one it's pretty simple. So you have whatever inputs you're gonna have, you translate them into tensors, which is basically an array or a matrix. I think it's an array, a tensor of numbers that represents the data. Then you feed that into the network, which is basically just this graph of operations. So through the class, you pass the data. I think it is a tensor, and then the node itself, the class, the object that encodes the information for the mathematical equation is going to use that tensor to perform the other steps. So for the normal, I think for the ones that are probably used the most is just the data times the weight plus the bias. And then data times weight is going to be a matrix operation, so you do everything at the same time, I think. And then the bias is basically adding the vector to the matrix after. Then you have the activation function, which is to determine whether or not, like the strength of the signal of that node into the other nodes. Then the backwards propagation is basically once you do the mathematical operation on the data, you're going to get a value. I think you get, this is the part that is confusing, but I think you get, it depends on how many outputs you put on the graph network. But I think you get like tensors as values, and then each tensor has a probabilistic distribution because you went through the activation function. So the purpose of the activation function is to collapse everything into a range between 0 or 1, I think. And then from that point, you have a range of what is most likely, what outputs are the most likely. Then you basically subtract that with the reference frame, which is the data set you're training against. And that's is going to give you like the delta between what you're aiming for and what you have. Then you use that to do the gradient descent, which is basically the derivative of the whole graph through the chaining rule. And that basically, then you upgrade the gradients, and that basically adjusts the mathematical equation, the weights of the mathematical equation to get closer to the data. It's like you're encoding the latent space. And the way that the thing that is slightly confusing, that was slightly confusing for me, is that initially I was thinking that this value here was the main thing that the network is. But this is actually just the atom that he uses. So yeah, it was confusing because of the backwards here, where he does this topological sort. So it's like a recursive function, I think. Yeah, here. So he calls on these nodes. Then he puts on the cache here to mark the ones that were visited. And then he goes backwards. Then he reverses this and calls backwards on the other ones. But this one is kind of confusing to me. It's confusing because to imagine like the relationship between this one with the rest of the network. That's the thing that I kind of confusing to think about. The other thing I'm not really sure how to do is these functions here. So in Python, these are operator overloaders. They basically allow you to determine what's going to happen on mathematical operation because Python doesn't know how to do this by default. So here you're telling Python how to subtract the value object with another value object. The other one's basically the same. I guess this is just a graph uses to show the thing. So this should be the same, that same file he uses there to go over the tutorial. Batching is going to be hard as well. So batching is like splitting the data so you don't do everything at once. Doing batches. Splitting Rust, I think it's going to be kind of hard to do this. Ask GPT how to do the operator overloading Rust. To install is cargo ads or something like that. Hello. So the obvious problem is gonna be, I remember if Rust has this thing here in the end. I need to figure out how to do operator overloading. Then the hardest part is gonna be the data and the inputs and outputs. How do I? Because data might be annoying to get the data, and there's like, because here I think he's getting the data from Python, from the sklearn library. It's probably a default data that they use for examples and stuff like this. I know Kaggle, or however, whatever way you say that, is a website, has a bunch of datasets for free. So let me try to understand what he was training the model to do here. Yeah, I guess I'm just gonna ask GPT. Probably knows as well what he was trying to do. So the optimization is basically just a loop. So cause the loss here. So he loads the data here. From what I remember from Kaggle as well, on this, the way you do it is basically you get a data set and then you split. I think he talks about this on the videos as well. You split. I think you use 80% of the data for training, and then the other 20% should test training. Because if the weight, I don't know how to say this, but if they get adjusted only for that data set that you're using, then that's called overfitting, because it means that you're not going to be able to generalize the model to other situations. So you have to leave some part for the validation of the model. But I'm not really sure. I think that the X and Y, maybe that's what X and Y are here. X is the training, and then Y is the validation, maybe. This MLP is multi-layer perceptron, I think, and it's basically the network. So the way it works is have the value, which is the building block, that allows you to encode an operation, the state of an operation. And you have the neuron, which uses this atom to build the layers. Basically, using multiple values to build. So each value is like the node on the network, and the neuron is the layer. Next to, I think that's, no, neural. So the layer is here. What does this do? I think it's just encoding the activation. So this is an array of values. Are the weights. So this, if I understand correctly, is just basically doing the mathematical equation. Those weights times x, which is the input here. So you pass the data, the input data to this call. Then this is basically going to multiply the data with the weights, which start at random values, and then add the bias. And then you do the value, which is an activation function. I think it's reticular linear activation, some shit like that. I never saw this before, but apparently you can do this, I think. So I think the way that this works is that it's only gonna multiply the gradient here if this is true. Otherwise, it's gonna be 0, I think. Yeah, otherwise, it doesn't run. So it's basically a no-op, mean is 0. So if the value of the activation is greater than 0, then it adds that to the gradient, I think. Oh, so I think that what's happening here, so what I assume is happening is that in Python, this is probably the overload operator for the call. So when it's doing this here, it's basically calling this function here. So the activation for the layer is just basically going over all the neurons and then calling the mathematical equation here, and then I'm calling the activation function. It's basically calling for every one of them. Parameters is just the matrix of the equation, I think. So the tensor of weights plus the bias. I'm not really sure. I'm gonna ask ChatGPT this. I'm not really sure about this operation here. I'm not sure if it is appending this bias to the end of the. I think it's probably appending the bias. So this is just gonna return one array, which is basically like a tensor or a vector. And here it's basically the same thing, just calling for each layer. So the entire network is just a bunch of layers based on whatever parameters you pass here. This is the number of inputs, number of outputs. How does he decide the layers here? How many layers? So here, the number of inputs determine the size of this array here. So the number of weights, obviously. That makes sense. And the number of outputs. Like, I can intuitively like understand what he meant here. Not really sure if I get it, but I assume it's non-linear. It's just checking to see if the number of outputs is different than the number of inputs. But I'm not really sure how that looks on, like, how does the network determines what the outputs mean in the end? That's what I want to understand. And after he calls here, it's just gonna it returns the vector basically. This is kind of weird. It's kind of confusing to understand. Because here it doesn't seem like it's determined by the number of outputs here. It's determined by the number, like the size of this vector here is determined by this. Oh, but this is probably determined by the size of the, yeah, the outputs. Oh, that makes sense. So you pass the number of outputs you want here, and that determines how many neurons it creates here, based on the number of inputs here. The inputs are like an internal thing that only matters for the neuron here. Determines the size of this object. The outputs determine the size of how many neurons you have on the layer. It's still kind of weird. Don't remember how it works in, I think it's LATS too. There's probably gonna be a candle type that I have to use here because obviously it's not gonna be like, maybe array makes more sense, but I think array. I don't know. I don't. Not sure if there is a array in Rust. Obviously, I have the bias. For the bias is Very similar, I think. Or I can just use the bias as the last value on the weight tensor. It probably makes sense to put them as separate values. But then I'm not really sure how I'm gonna do the thing that he does here of adding the bias to on the parameters, adding the bias to the weights here. This determines how fast you move based on the loss. To try to find the minimum or maximum minimum or maximum local optimal. Here I'm not really sure what to do as well. Should I do this? Not sure if that makes sense or not. It is a problem that I'm not sure how to solve this. Like when using LLMs to learn, that they just give you the response, but I'm not really sure if there's another way to go about this. It's hard to think about how to go from zero to learning if you don't know like what to do there. It's more about like I'm trying to pick up the practice of building because I already have a good understanding of how the concepts work. But then if you use the LLM, it's just gonna give you the response. Maybe I should ask like for smaller questions. That's probably what I should do. There's the data as well. I wonder if I feel this is gonna allow me to go to the definition when I do F12 here. I want to spend some time studying the Kendo code to understand how the tensors work and how do they do the operations with the tensors. I'm trying to think about if there's an easier way to do this on Rust, or just an easier way to do it in general. Yeah, I guess like the confusing part to me in the beginning is that each one of the atoms does the entire operation for for the whole thing. It seems that's the part that is kind of, because obviously you can think about like not using any classes or structs, just using the tensors basically, and then multiplying the tensors. That would be simpler, but then you lose the causality, I think. I think that's the point of having the class, which is more annoying to set up. I'm not really sure how I'm gonna do it in Rust. If I can go here. try to restart this code, see if the Rust analyzer works. Otherwise, it's gonna be annoying. Sure how Rust works with the libraries. You might not be able to look into the source, so I'm gonna have to go to the repo and then view manually there, so it's gonna be more annoying to do. But I think it's the problem is that it's trying to get the wrong, because the workspace is not like the workspace is assuming that I'm on the main folder instead of the folder that I'm doing the Rust thing on. But I think the easiest alternative in order to not deal with having to go over manually the thing or figure this out is to open another VS Code and try to see if it works here. And I have both, one to look into the Python code, the other one to look into the Rust. And maybe I will solve this later. I see how to change Rust Analyzer so that it understands that the Rust is on the subfolder Rust project. Let me think about. I'm also not sure how matrix operation works on Rust. And it looks like there's a bunch of wrong things here. I think to make this have to. I don't know how to. Maybe I have to do a mod file. How to import in Rust. I'm gonna try to compile first to see if I can go there to the definition. I don't remember how to do this. Yeah. I think you need to add Candle car. Then maybe candle transformer as well. Should be able to go to the definition now. At least this one can go. Maybe after finish compiling, I'm gonna be able to go to the tensor definition. Shouldn't I be able to do this with a struct as well? Also, is implementing the enum, I think. The value. So you implement something for the struct, that makes sense. I confused the two there. Yeah. On Rust, the downside is that like you depend on the for these kinds of things. I think that's but C++ is kind of bad as well. The tools for going to the definition stuff, the compiler toolchain is kind of annoying on both. But once you get it to compile on C++, I think it's usually better. Usually the extension or like the built-in. I'm not really sure if I use a built-in thing for C++ or if I use an extension. It usually works, but for Rust, sometimes it doesn't. You have to manually search for the things. Kind of annoying. Broadcast is the like cloning the values so that the matrix matches, I think. So if you have different shapes on matrix multiplication and you don't broadcast, you get the wrong value in a lot of places. And I think broadcasting just copies the values. Andre talks about this on the playlist there as well. I'm not really sure how if it is different or not in Rust here or in Python. But I assume it's obviously gonna be the same thing. This also in Rust is not the libraries that are not on this repository. They are added on this on the Rust path probably on the OS. Interesting. Let's go back again here on the on Android. 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 I think instead of implementing the overloader myself, I can just use Candle. It looks like in Rust to implement the overloaders, you have to do it like this. So you implement the struct, you create the struct, and then you implement whatever functionality you want through this implementation thing here. I don't remember really well how this works in Rust. Because it's kind of like a class, but it's not really like a class. It allows you to have more flexibility. It allows you to add behavior to an object, but not bind the object state with the behavior. But I don't remember, like if I do an implementation of add, multiply, and stuff like that, if it's gonna be like perceived as a separate thing. I think it's probably will. So it's not really like the same thing as it is in Python there. That's the thing that is kind of annoying. So should probably try to figure out how they implement operations on the tensor first. So I can clarify how to build a mathematical equation. And then I think about the big picture of what is the best way to connect the nodes together. That's what I'm thinking about. Because obviously the equation is very easy. You just multiply the weights of the input data, and then you add the bias, then you call the activation. But I'm not really sure how to do this on every node. What is the best way to do it on every node? Perfect. This. Obviously, I can copy here. Where they do this. I want to understand what's are all these other things. So here's probably the methods you wanna use. Wanna use CPU or GPU with CUDA, and I think Metal is for Mac OS. I think you kind of do. You kind of have to implement some sort of like the same way that the Andre does because of the backward propagation. Otherwise, there's no way to anchor the state of the equation. Yeah, but the question is how to do like the details are kind of annoying because I don't understand. If I say that the weights are a tensor, I think that I don't need to initialize on the child like maybe like this. Yeah. Yeah, the question is, do you have to initialize here? And the way that I was thinking about the operator overloaded before, operator overloading, if the way that they are doing there is the way that it should do, it's probably gonna be something like this, but kind of weird because then I think that's like this is not really the same thing because this would be a class there. Like doesn't make sense. So I'm not sure. Hmm. I think I should just put like a different like a underscore here and then just implement value and then just do self. I think it's self on Rust. Do function adds. What I'm gonna do is just copy the Python code for the functions and then translate them into Rust. Let me see if I can remember from memory how it works for the add. I think you don't do the weights to do the from what I remember from the video is grad and the data that you add, but I don't remember really well anymore. And like that doesn't make sense. Yes. And then it depends on the way that the tensor works as well, which I don't understand very well. So obviously I know I have to initialize with this thing here. I think that I don't understand macros in Rust very well as well. I'm just gonna ask ChatGPT how this works. But I'm thinking that these are the operations, like the implementation of operations on the tensors. So I'm guessing that this is the way that you create. Like initially, I put there, you do this new, and then you pass an array, has this type here, and the array probably comes with their library as well. Yeah, it does. And then you pass the shape, which is the dimensions of the array. So you can kind of imagine that it is like a matrix, I think. Depending on the dimensions you pass. Yeah, I think that the confusion that I have is that I'm conflating the multiplication of the matrix of weights with the vector of or the tensor of bias, and then the activation with the network as well. But it's like a bunch of matrix operations, one for each node. I'll be right back. So first check to see if it is an instance of the value and that's the data. So is that in the input? Creating another value. But I think the confusing thing is that here the data is probably the weight, maybe. I'm not really sure though. It is again. Yeah, so the data is the weight. I think that's the thing that is confusing me. It's not the inputs. So it does add the weights. Or maybe not. I think I have to see on the real example to see how initialize everything. It's kind of hard to understand. Like, it doesn't make sense to be the weight, but I don't understand there if it is like on the initialization here, if it is on this map is passing the data, is initializing value as with this X row here, which is the data. And if that's the case, then the data here is actually the input. But then it's kind of confusing because on the other one, it is like making this equal to the weight here and initializing. I guess it's just basically the same thing. It just depends on the way that you initialize. But that it makes it kind of confusing on my mind to understand. Oh no, the input is gonna be passed here, so it is the weight. Yeah. So the data there is the weight. The inputs pass here on the initialization, and then it multiplies here. Yeah. So the graph network is like the data is an external thing, and the structure of the graph network just encodes the values of the equation, like on the state. And they hold the state of the equation. The input is like an external being passed to. Hmm. So my thing there it would be the weight, I think. This is confusing as well because the equation is obviously like inputs times weights plus bias. But there he's doing like this, then like how does this make sense? Because when you add the bias, then it's gonna be the ads gonna be the bias plus the thing. Because the ad's just a value, and the value, yeah, it's confusing because the names are the same, but the value becomes a different thing depending on how you initialize it. That's the confusion. So the real thing would be like the real operation would be like this on this case here, because I'm being forced to call a function instead of doing the operator overloaded thing. The reason why he does the plus by adding the data on the other one is because the values are the same, but they are initialized in different ways. That's the thing that I'm thinking the most here is that if I'm gonna do things like this, I don't think it makes sense to. I'm trying to figure out a way to do things in a different way than he did there. Because if I can't use operator overloading, I think that it doesn't make a lot of sense to create an atom object like this. It probably makes a lot. It probably makes more sense to. And maybe I'll do different implementations. So instead of having the weight here, yeah, but then it doesn't make sense either because I would have only one value, only one tensor. So maybe I just implement the tensor. I can implement different functions for the tensor that encode the equation. And then I just receive the inputs and outputs. Done. I'm not sure if I do this, if it makes sense or not. Or the other way around. I implement something for the tensor. But I guess this should be a struct or something like this. Or a trait, like they say there. I still don't understand based on what ChatGPT said there, what's wrong with the that I was trying to do this. I don't understand why you can't use a trait here, struct here. Oh. You can understand what I'm getting confused by is that like I'm seeing the trait or the implementation as adding functions to the struct, but I'm confusing the implementation with the trait. So the struct is like a building, and the trait is like the highways that connect the buildings together. Then implementation would be like, how do you wanna, which path you wanna use? I think that's how it works. Yeah, so what I meant to do was to implement the struct. That's the thing that was getting confused. But I'm thinking maybe it's better to try to do like this, where I do the whole thing using, because the tensor is already all the logic for the operations. So I could have a function that receives the inputs and outputs, then creates the tensors, and then just builds everything on a loop. Like it just calls the equation basically, based on the number of layers, number of inputs and outputs. Sure, why is whatever. And that's the thing that is confusing. Is the thing that I was talking about before again as well. That because since the structure of the network is it is kind of like a matrix, you confuse the structure of the network with the operation, which is also a matrix. The operation is done for each node in the network. So I think here, for example, it could be just a tensor each one, and then I determine the number of inputs that I want based on the nature of the tensor. That honestly, I'm not really sure how it works, but I'm imagining that it is a kind of like an array or a vector, each tensor. So I could initialize the tensor for with the size of the inputs here instead of creating a vector. That's probably better, but then it's kind of confusing because then how do you do the mathematical operation? Like what would be the correct way to do it? Yeah, like I have to create another class. I can't use the tensor. I need to do the same way that he did. Because then, like, I'm not really multiplying the layer. Each layer has, it can encode the operation on itself, like on the nodes of the layer. The layers are not values, they are nodes. That's the confusion. So I would have to do another struct and then use the tensor on the struct to do the calculation. But that's the thing. Maybe it is better to try to do it like this, and then you just do the operation multiple times. But then the problem is that you're gonna lose the state. That's the issue. Like you lose the weights if you do it like this. Yeah, I think that this is the point of having the thing as a class. It allows you to encode the state, like to capture the state of the mathematical operation. Uh, hmm. Yeah, I don't think that there is a way. Also, I'm gonna have to use this probably for reference counting, which I don't know how it works very well, or at all actually. But I think that's the only way is to use this. Then you have the weights biases here, like he does there on the original thing. And maybe actually, if I did it like this, it would be slightly different because I would have the data here. So I wouldn't need another class, but I think that might be more confusing. That's the reason why he did it the other way. Because like in his version, he doesn't have this data. He has only the. He doesn't have these weights. He has the data. He doesn't have the bias. But then he uses the same class for multiple purposes. I'm thinking about encoding the equation on only one struct, and then I just reuse the same struct everywhere. And on the for pass, I just change the functions. Not sure if that makes sense or not. Problem is the call. How do you call? I'm not sure if I should spend time studying this other stuff before. It looks like the hardest part's gonna be managing the memory and the references, stuff like that. Not sure if I spend some time looking into the source because it is relatively easier. Like to copy is relatively easy. You can just manually translate one thing at a time, but I want to understand. I want you to think about what is the best way to do this. And it's kind of confusing because obviously it's different the way that the types work in Rust. So obviously here I could do basically the same thing that he was doing there and just change just slightly change the way maybe, but I'm not sure how this works. Hmm. Because it is improving my understanding of like why it is done this way. So the structure, the classes in the structure, the purpose of having them is to hold the state of the equation. So the inputs are passed as parameters because they don't matter, like they are always going to be the same, and they are not meant to be captured by the gradient descent. And the other values, they are part of they are part of the structure that creates the mathematical equation because you want to keep track of their state. So I think that this part it has been helpful so far to clarify this. But the part that is most difficult and annoying to think about is like how to, because then like you have polymorphism and you can, maybe there's different ways you can implement the type. And also like I'm not familiar with Rust at all when it comes to macros and other stuff like this. So I'm not really sure what's the best way to, or even how to do it in Rust. And also like the tensor, I'm not really sure how it works. And this stuff here. So maybe I should spend some time just going over with the LLM, see if I can clarify how the libraries work, how this other referencing works. This is another annoying thing that I'm not really sure how to think about, which is how to keep reference to the parent. And I'm not sure if I understand here as well. How does that work? It looks like the value doesn't, like none of these classes keep track of the parents, I think. So it just creates uh, mathematical object and then uses the same object for different parts of the equation, I think. The other classes do the math equation inside of the function, the call function. Then each value encodes the state of the overall equation. But it doesn't seem that it keeps track of parents anywhere, as I don't understand how it works. Yeah, but it seems like it always passes think the input's gonna be would be another value as well. That's how they are doing there, and then you would just. I think in Rust you can't do the looping in one line, so it'll probably be a vector actually, vector of values, I think. So here is gonna be a number to create the thing, but then this becomes a vector. So you loop over the vector. So I think it is a tensor. So, but then what's, because this is this is like it isn't a tensor. It is a vector of values, and then inside of the vector of values, it does the multiplication by calling this function here. So just multiplying the values, and then it captures the value inside of the function, inside of the object. So this would be a value. And then the difference, yeah, I was gonna. I'm not sure how you do this in Rust. Not sure if it's like this. And this would be, we have to be, we have to ask how to do this vector to all of them. I think the idea I get, you loop over the weights and then you multiply by the value. Then the weights would have to be a value as well, I think. Um, so obviously here I'm missing another class there. Like the one that I'm trying to do there is the narrow. Yeah, so I kind of, I get it already. But I don't wanna, I think it's a waste of time to just copy the classes one by one and then just rewrite in Rust. I think it makes more sense to try to think about how to do this in a different way because of the way that the Rust works. Maybe there's a better way to implement this. The implementations, and like it's gonna be annoying because of the reference. I don't wanna waste energy on that. I guess I'm just gonna ask this. Not really sure what exactly is a layer in the mathematical sense. I can think about as being this space that each equations changes. So, like the neuron is obviously the encoding of the mathematical equation. So the value has the functionality. It has the structure and the functionality to make the equation possible. The neuron determines the shape of the equation by determining how the values are going to relate to each other. But then the layer is a little bit more subtle, I think. It determines the region of space in which the equation acts on, I think. Kind of like the fiber of the space. The MLP will be the space, which is obviously relative to the data. Yeah, that's what I was like. I'm not really sure about the details and the nuance, but like it just seems intuitively that it doesn't make a lot of sense to because like I think about the structure in Python to be more rigid. So like each class is its own block because you're forced to put the functions and the data in the same object. But because Rust has the separation of implementing the object separately from the path, which are the functions, like functions are paths between objects that change them. So because of this and because the neural net is basically just a connection between objects that holds the state of the values, I think that intuitively makes sense that there should be an easier way to do this in Rust that allows you to encode the structure in a way and then you do the edges on a so like you use only one struct. And maybe you need like one for each layer, and then you do need another one to encode the relation between the layers, but not for sure. Because I think that you can encode the path between the nodes in a trait, and then you can encode the nodes on a struct. I'm not sure if trait. Yeah, and then the implementation would be like the path from one node to another. But I'm not really sure makes sense or not. This is extremely annoying as well. It's like dealing with the borrowing and references. Like it's gonna be very hard to do this. Okay, so what do I do? Does the bias change? Where's the bias? Is one bias for? There's only one bias for. No, but each neuron has its own bias. So. The bias is a scalar and the weights are a vector. I'm thinking I could have vectors of values, and then each value I put there in the whole equation, but I'm not sure if that makes sense. I, I, I think it would end up being the same as it has here, probably. I think the only thing that I'm thinking about is not doing this one. Oh, there's shadow here. Oh, shadow. Hmm. It does keep track of the children. Yeah, that makes sense, obviously, because then how else would you connect nodes? I keep circling back to the same thing that because when I think about a neural network, I think about the nodes connected on a graph, but then each node has its own tensor. So like it's more intuitive and natural to me to think about the network as the tensor itself, like each layer as a tensor. But then each one of those is not really a value, is a tensor as well. So that's the part that is very confusing. I think that each value, so for here, for example, if I'm thinking about creating each node, I would have to need a tensor here instead of vector of tensors, is just a tensor. And then this tensor holds the values for the previous layer, but that's the part that is kind of confusing. Because yeah, the connection of them is the thing that matters. Like how do I ensure the connection is correct? I think that's the part that is confusing me, because then the size of this tensor here has to be based on the previous layer. It's still kind of confusing to understand here, but it feels easier, I think, to understand here. And that's the thing that. So they initialize based on the inputs here. So this determines the size of this thing here. Then how do you ensure? I guess like since every input, since every node is gonna get the same layer, the same input, then it doesn't matter. I'm not really sure if that makes sense or not. Because it's just more natural to me to think about the whole thing. That's the thing that here is separate. I'm not really sure if it is the input is like values or tensors, and then this is a matrix. I think that's probably this is probably a matrix. Like it is XB is a matrix, and then each one of these is a row. Yeah, based on the name, makes more sense. So the inputs would be values. Then each value contains a vector inside, which are the. But then it is kind of confusing. So for these values, the data would be the inputs, and then these inputs are passed to the model, which would call the model here. This is the layers, then it loops over the layers. But this is the thing that is confusing. Fuck. No, the layers are here. So in the beginning. Yeah, so it's passing the input here, then the input goes to the layer. There was created in the beginning. Yeah, I think this is the part that is confusing me, because it's natural to think about the inputs as being part of the state of the class and not received as an argument. I'm naturally thinking more that the input's gonna be used to create the layers. That's more natural to think about, because that's how you think in your mind. Because you obviously when you see the network, you see the inputs like the graph. So I'm imagining the inputs as a static thing as part of the thing here, the class. and he's decoupling he's initializing based on numbers. That's the part that I don't understand why did it like this. The question is, if I don't do like this, then how can I do there? I think it makes more sense to have the inputs as like values, and also to maybe it does make more sense to use the same value object for everything and then just change the way that you initialize. But I think it makes more confusing to understand. But it's more natural for me to think about it like this. But then obviously this wouldn't be, it would be vectors of values the way that I'm thinking about. I don't know how to do a vector on Rust. So I'm gonna ask an LLM, but that's how I'm thinking now. To initialize an object, then each part of the network becomes a vector of that object, and then you connect the nodes based on functions. Or maybe I can create, maybe that's the implementation. Yeah, this is the part that I'm struggling to understand, to clarify. Is what is the relationship? Like, I'm thinking about the weights as being the values of the previous layer. Then how does that work? When you have a second layer, for example, are the weights the data of the previous layer? The data from the nodes of the previous layer, and then if yes, then how do you ensure the tensor operation is correct? Because the dimensions could be off. That's what I'm trying to think about. I'm not pretty sure, like if it's the weight of the previous layer multiplied by the data of the current node, because then that would mean the data. Actually, not. Maybe the data can be a scalar because then it's just multiplying the value. Yeah, what is the data? In the first pass, I think that's like for the input nodes or for the first layer, the data would be the input. Not really sure if that makes sense or not. So if this is the input, then it goes here. So each one of these is the value, then each one of these has a weight or has a vector. Right? Maybe the value, maybe this is just one value. No, but the weights are gonna be like this array of values. So maybe that's what I'm confusing. So this is just gonna be one value. It's confusing because here, like, this is just one value. The data is just one value, but then this has children. So how does that work? And then like, the on here it doesn't seem that it creates children for any of the values. Like the neuron is gonna like it looks like the weights are just random numbers in the beginning for each node on the network. They are not related to the previous layer. So each node has its own state, but then how does that? Oh no, it is related to the number of inputs, I guess. So this guarantees the shape. But then the question is like, how do you initialize the? That's the part that is confusing. I think that this network only has one layer. No, it has more here. Because here, like, I'm thinking about because I think normally you're gonna have more nodes in the in the layers than you have on the inputs and outputs. But it seems that here, like, it is capping the size of each layer to the number of outputs. So that's the thing that is weird to me. And then it's capping the inputs to the number of inputs here. I guess I don't understand this line very well. This non-linear stuff here. But it's still kind of confusing because it seems to me that it's forcing the layers to be all the same size. And all like the same size as the outputs. No, here. Oh, so yeah, I'm confusing the layers could be different sizes because of it. No, but actually, because this is never gonna change, so it's the same for all of them. Just passing the inputs. was for each input creating a layer. Which is also kind of weird. Like it doesn't match the picture that I have on my mind of how the network should look like. I guess I'm just gonna ask that to Gemini. Bias would be just a scalar. Yeah. Or I think in this case, I don't have the data here. So I don't have the inputs. The inputs is not a vector values. It would be something outside. It would be a tensor. But I guess it depends on what you want to do. Like how do you want to train? And it depends on how the tensor works as well. I don't know. Because the tensor could operate as a matrix, I think. So I could make it so that it's always a tensor, and then I figure out a way to shape the data based on the tensor. Like I initialize the MLP passing values for the x and y of the matrix, or however way I want to do this. Then outside I decide how to convert the data, embed the data into this matrix format. Then the implementation will be just doing the equation. Like I would have the forwards here, and the input would be this tensor, and then I would just do the equation here. Like return weights time inputs plus bias. Sure, if you have the This would have to be like a single layer, because the number of layers would be vectors of vectors. Imagining each layer as being a vector of values, then but I'm not really sure if that makes sense or not. Like you loop over the layers, and then for each value you call the function the for function, and then the for function, each value captures its weight as a tensor and the bias, and then yeah, I guess the gradient as well. And then I would have a backwards pass as well. Need the activation function as well. Don't remember receives anything. Just gonna copy. Oh, it is like it doesn't make sense. Because there the value is just a value is not a tensor. But the levels are very confusing because I'm trying to do something else. I can put the data here as well. Like the data would be the value of the output. Then on the forward, instead of returning, I just change the value of the data. Yeah, I think that's probably the correct way to do it. But obviously, I'm not really sure about this. Then here would be shift self.data. Self. I don't think that's to have this for us. I don't understand why he defines the function inside of this other function here as well. I think that he does this. It's kind of weird to be honest. The one explanation is that on the rest of the graph is gonna make sense because you're gonna reuse the value. You're gonna use the other value once you call this. Like he calls relu, and then the one that returns is use. Yeah, here. So when this neuron is called, here the out's gonna have that function, but it's still kind of weird. Yeah, I guess like here, on the end there, on the loss is gonna, this is gonna be the outs, and then each one has, because it changes the function every time that he calls. So when he backwards propagates, he's gonna have the updated gradient, I think. Updated, dated, and gradient. That's why he does it inside of the function. But I don't think that he has to be that way, probably. It's easier, obviously, just as the LLM. I'm just trying to clarify, like, in rough pseudocode, if I can do it this way that I'm thinking about. So each value contains the equation, the states of the equation for that node. Each value, so this would be like a node. Then so hmm, I'm thinking that I don't need to have three values here, because obviously if you think about it, it's just a graph. So I just need to ensure that the edges are in one direction. That's the question that is the most confusing. Is how to do the connection between them correctly, because they depend on the activation, obviously. So that you do the for pass correctly. Yeah, so instead of thinking about inputs and outputs, I could have just edges and nodes here. The question is, what would the edges be? The nodes are the weights. The edges should be the equation, I think. So maybe it makes more sense for this to be the edge, not the node. Yeah. Not sure though, that makes sense. I'm gonna ask Gemini to see what it thinks. And then this would be just like a vector of tensors, and then this would be a vector of edges. So each connection between nodes is determined based on the activation, which is the weights times the. And this is the part that I'm not really sure as well. The inputs, that is kind of confusing to me. I think that this is just data. It's not. Yeah. So the weights times the data. But then the data is not on the edge. Hmm. Maybe it is. I'm gonna ask Gemini to see what it thinks. I'll be right back. Yeah, I just struggle to implement because I'm not familiar with Rust. And also because it is confusing. I'm not really sure if I should try to just copy and paste the implementation from Python and then spend time trying to like going over the friction of learning the this graph cell and the memory management side. But it's like intuitively it just seems more annoying to me. Seems like lower ROI, I think. 'Cause I already understand the in Python, even though it is confusing to get the nuances, but the big picture is very easy to understand. Like it's just creating the equations here, as I said, like it's just creating the object that has the structure of how to do the operation, and the other classes are just compositions of this structure to create the flow of data. The changes, the state of the weights based on the gradient descent, the backwards propagation. But I'm thinking that's probably not worth it to just copy and paste and then try to spend a bunch of time figuring out how to use the other classes or the other structs. The thing that is most confusing to me about the value is the children there. I'm not really sure how that works. I'm gonna watch the videos again on the playlist, and maybe this time I'll catch the explanation. I don't remember if he explained that or not. The thing here is that it doesn't encode the bias, so I'm gonna ask that. It doesn't encode the bias, and it's not clear if I should implement the edge here. But this way makes a lot more sense to think, because the other thing that I'm thinking about is obviously the optimizations on the GPU for matrix multiplication. That's the thing that I'm saying multiple times, which is very confusing. Like when you think about the network, obviously you think about a bunch of nodes connected through edges, and then it's easy to associate that as a matrix. So connection, a bunch of tensors connected through edges. Then obviously each one of the nodes is also has tensors to encode the values of the other ones, I think. But this part is the one that I'm most confused by. It's much more natural to me to think about it as a graph. And then the weight of the edges, like, is the friction to activate the node. Yeah, value times weight. Actually, I remember he used the tangent for the activation. Now I'm not really sure the relationship here. The series is obviously using Rallo. I don't get it. Maybe here he used Rallo, but on the video he uses tangent. And the backwards. Yeah, this is the thing, is that like he shows on the video there that the derivative of the partial derivative of the multiplication is just gonna be the value of the nodes times the gradient of the other. And for the sum is just the value of the node, I think. No, sum just increases the gradient by the other one, the gradient of the other node, because the other one becomes a constant. And it becomes 1 on the partial derivative. So obviously, like this is the local derivative, and then the because it goes backwards through all the nodes, encodes the chain rule of all of them, because they're summing the gradient. So on the multiplication is the data of the current, or actually data of the other. There's the data of the other times the gradient of the current. So yeah, I'm gonna stop streaming now, and I'm gonna watch the playlist again. Probably next time I'm gonna continue to try to learn this. But I'm still confused about the output thing because I remember from a long time ago from doing Kaggle training or their courses, and also from seeing the code there that you split the data, the training data into the training sets and the validation sets. But the thing that is confusing me and I don't understand very well is how do you know what the output should be? Like do we, for the input do we always put the like 80% of the training set as the inputs, and then for the outputs for training the loss function, do we subtract against the validation set? And then how does that work? Like how does the encoding of the how does the encoding of the output works? Because you can imagine that you can have an arbitrary number of outputs if you want on the neural net. So how do you make sense of the values of those outputs in relationship to what the data is? Because the data could be anything really. So it could be an image, it could be letters, it could be anything like embeddings of. Obviously, the representation is going to be in numbers, but then like what the data means could be anything. So I don't understand how the output nodes of the network are used on the loss function to compare against whatever that data is going to be in the end. That's the part that I'm confused about. And also like this thing here that Gemini said that there are two different ways to do it. So intuitively to me, this way that I'm trying to do with Gemini here is makes more sense, where you create the graph and then the flow of information through the graph is encodes the mathematical equation. That's how what's I was thinking. Like the edge is like the friction on the network. So if you have a high number for the edge, it means that there's more friction from on that part of the network from one node to the other. And that automatically should train the network based on gradient descent, obviously. So gradient descent would determine like what is the correct friction of the edges in order to have the correct output based on the inputs. And the way that Andre does is slightly different, I think, because he's encoding the structure on the object, and he doesn't have edges. So it's a little, but I can't say like clearly how does it work because Gemini is saying that on this way that we are trying to do, you don't have bias. You don't need to put the bias on the equation there, and that's why it didn't put any bias here on the edge or on the value. Because the weight of the edge, it's saying that the weight of the edge would already be the bias, and the value would be the weight here on the node. But this part is still kind of confusing to me in how this relates to the other one that Andre has. The clean way. In your edge-based model, you have two choices for attributes B. Every node has a bias field. Yeah, that's what I was thinking. Every node has a bias. I wasn't sure about if it is the node or the edge that has the bias. So I guess it makes sense to be the node. After the edge delivers their weight times x comes to the node adds its own internal bias. The relationship between weights and inputs is also very confusing because we can have multiple different layers, and I'm not really sure how each node should view the what determines how many weights each node has. That's the 'cause in the way that I think that intuitively I think that each node, the weights that each node has are the layers, the previous layers. But I don't think that's the case. I'm not really sure if that's the case or not. I'm gonna stop here and I'm gonna think more about this upstream. I think probably tomorrow I'm just gonna continue to study this. And I think that I'm probably not gonna be able to implement because I'm not gonna have enough time to study everything. But maybe I am going to be able to. Because the most annoying part is definitely this, like the data, the references and stuff like that. But I'm gonna try to watch the playlist again, then see if everything. I don't think it will become clear because I'm trying to do something slightly different than what he's doing there. But I'm gonna see if I talk to the to ChatGPT or to Grok about this, and then maybe I'll try like to implement this, continue to implement upstream. If I clarify, the next time I if I implement anything, there's a bunch of things to study as well. So I don't think I'm gonna do this. So probably not next time. I'm just gonna continue from here, trying to figure out what to do this. So see you then.